Hello and welcome to the Week 9 video broadcast. I want to just go over a couple of things with regard to some of the statistics primarily that are incorporated into the conclusions of the study using clickers in class, the role of interactivity, active collaborative learning, and engagement in learning performance. So I'm going to go ahead and turn off my video camera so that I can use a little bit more of the screen for some of the screenshots that I want to talk about. The first thing that I want to draw your attention to is this figure 1, which is in the article. This is it's a very common way in current research that researchers try to share with the reader what it is they think that they're well, not only going to find, but what it is they're actually testing. So the authors of this particular article believe that the use of clickers promotes interactivity with peers, and then as a result, interactivity with peers results in more active collaborative learning. They also believe that interactivity with peers contributes to engagement, and they believe that engagement contributes to learning performance. They believe that the use of clickers promotes interactivity with the teacher, and they believe that that contributes to active learning and also engagement. They believe that active collaborative learning contributes to engagement. So basically, when you see all of these different arrows, it's a way of helping the reader understand the nature of the relationships that the authors believe they're going to find as a result of using clickers. So they're looking at a cause and effect type of relationship between multiple variables. The use of H1, H2, and so on through H7, these are the various hypotheses that the authors are actually testing in their model. So they're going to determine if indeed interactivity with peers leads to active collaborative learning. They're also going to test whether interactivity peers leads to or contributes to engagement, and so on for each of these 7 hypotheses, and they're looking at them in the direction that you see the arrows. So this causes this. This causes this, and so on. So the direction of the arrows is important, and the arrows themselves in terms of what they're pointing to specifies their belief of cause and effect relationships. As part of structural equation modeling, one analysis that is very common is what's called confirmatory factor analysis. Now I have cut off 2 columns that are off to the right in Table 1 because I think that if we focus on some of the other things that's enough for you to understand to be able to make meaning of what's here. I've also cut off part of the bottom of the table as well. It's longer than what I have in here. So what I want to do though is help you understand what is here so that you can extract meaningful information. First off, the title of the table, Constructs, Items, and Confirmatory Factor Analysis Results. Constructs is the different elements that are identified through the survey that they administered to the students. So they're the big items, the big key ideas that emerge. So the survey had I forget exactly how many questions, but it had multiple questions on it. And instead of looking at each of the questions individually, what the authors tried to do is group those questions together in a way where different constructs emerge, knowing that not every survey item necessarily contributes to a construct. So the idea is that a statistical analysis can be performed to help the authors understand how each item on the survey can be related or grouped with other items. And then once the authors see how the items are grouped, they actually give the items a name. So one construct that they found is interactivity with peers. So the using the clickers in class, that's sort of the root of the survey item. And then this is the end of the survey item. So using clickers in class facilitates interaction with peers, gives me the opportunity to discuss with peers, and so on. So each of these is an item in the survey that is grouped with the construct interactivity with peers. The same thing here, except for now the construct is interactivity with the teacher. So there are 4 survey items that are grouped with that particular construct. And then another construct is active collaborative learning, and so on. So over here under standard factor loading, what the authors determined was that in running the confirmatory factor analysis, that they were only going to use items in which the value that was calculated in the analysis was zero 0.6 or greater. Now this is a correlation, and it's the relationship between each item and the construct overall. So they look at the responses of all of the participants and they see how the responses on each item correspond to the main construct. And it's a very sophisticated analysis. We actually don't even run it in the master's level class, but we do run it in the doctoral level quantitative class. But if you understand right now that the values that are included here are all strongly related to the construct that is identified, that's important. So if an item on the survey didn't have a value of at least 0.6, it's just not grouped with any of the constructs. So all of the items are not there. The R squared, which is in the next column, is just this value squared, and that tells you, knowing the response to this particular item for a person, tells you this percent of the value for overall interactivity with peers. So it's how much this particular item explains the overall construct. So the higher the value here, the more it explains about the construct of interest. There's also a table that includes descriptive statistics and correlations. So these are just the means, the averages, and the standard deviation. The higher the standard deviation, the more variation there is in terms of the way people responded to the items. And then these are the different constructs that were being tested and that the confirmatory factor analysis actually identified. So what we're looking at when we have the 1, 2, 3, 4, 5 up here, those numbers correspond to the 1 through 5 over here. And the values that are on the diagonal are the values that are the average overall R value or relation between that particular construct and the entire model. So 0.69, 0.78, and so on. So we're looking at among all of the items in that particular construct, the R value of those that were included, we can see comparatively which one was stronger. So learning performance was the strongest one in terms of the items that were in that construct actually explaining that construct. And then the items that are not on the diagonal but off the diagonal, so we pair item 1 with item 2, these are just the correlations between each of the constructs. So the relationship between interactivity with peers and interactivity with teachers is 0.29. That's an R value, a correlation, where we're looking at values under about 0.35 as being weak or minimal. Between 0.35 and 0.65 is being moderate, and above 0.65 as being strong. So we're looking at values here that are generally in the weak range. We do have a 0.61, and that is between active collaborative learning and engagement. So that correlation or that R value relationship between the two is moderate to strong. And then all the rest are, like I said, are moderate. And then the last thing that I want to explain a bit is just going back to the original model that the authors had. We see the 5 different constructs that they had identified. And then what we see is what are called beta coefficients in bold. Beta is a value that represents the number of standard deviation units that each variable contributes to the others. So they're all based on the same scale. We can compare them to each other. So a 0.20 would be stronger than a 0.14 and so on. We've got a 0.5 here, we've got a 0.67 here. So the higher the value, the more one variable influences the other, and the degree of influence is based on standard deviation units, meaning we're comparing apples to apples. And then the value that's in parentheses is a calculated t-value, which you can just ignore for now because that doesn't tell you quite as much as the actual beta value. And then the number of asterisks next to the beta values tell us whether the value is statistically significant. So the more asterisks there are, as long as it's 2 or higher, would suggest that it's not just based on chance, that there's a real relationship between the two variables that we can extract from the statistical analysis. So that's kind of it in a nutshell. I don't want to spend too much effort talking about all of the values. I think the ones that I discussed are the ones that are most critical for you to understand in order to really kind of get the gist of this particular study. I hope it explains things well for you, and if not, shoot me an email or post a question or comment in the class Q&A, because if you have a question, it's likely that other people do as well. Enjoy the rest of your week.